All right. Welcome everyone to the Globe Mission Earth webinar. We're going to look at the urban heat island effect and the urban heat island effect campaign. I'm going to do some talking at first, and then I think we'll have Diana Johns, her students, do some talking. And then we have a short video from Nektaria, who's a professor at West Virginia University and also University of Athens. So she commutes between two continents. So it's an interesting lifestyle. Let me share my screen here. I have to show you all the basic stuff, right? Let's scroll. Da, 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 da. Okay, here we go. All right, so we have to mention our funding is from NASA and our partners, Boston University, WestEd, Tennessee State, UC Berkeley, and NASA Langley in Virginia. And you know, our goal is to have students do projects. And I think Sarah, you're in one of these pictures here, right? Yeah. So you know, we want students to do projects, and one of the things that students can do is to base their project off of one of the campaigns in Globe. So that makes it you know, easy to connect, I suppose. So I'll just show you some of the ways that students can present. We have the Satellites Conference at the University of Toledo, May 1st. And of course, the International Virtual Science Symposia. All right, I don't remember what date. It's April, isn't it, the due date for that? Okay, we'll get some nods for that. Of course, we have the Globe Annual Meeting. Now, I did hear that they're limiting the number of students per school or per teacher to 2. So it might be an issue or something, right? So you may want to talk or register early and then try to get your students in. And then the Regional Science Symposia for Globe, and our Midwest is going to be in Iowa, April 5th and 6th. And then you see the dates here for the other ones. So if you're in those regions. Let's see. So, all right. So here's some talking I'll do about the field campaign. And these are the observations from December. And my grad student, Ishfaq, he did this analysis since, you know, it's nice to have people that can do analysis for you if you're sick and you can't do it yourself. So it's so nice that he helped me out. And so you see these are surface temperature observations. There's Crestwood coming in. He didn't put them in order, which is interesting. He just kind of had them random. Huntington High School in West Virginia, they do a lot of observations. Main Street, Marcy, her students have done a lot too. What's interesting is then the U.S. students are, you know, pretty well lead in the world too. But there are other schools that have a lot of observations in the world. But here's you know, Perkins, John, your students here, and then Jeff Bauman's at Shoemate. And there's a few other schools. Boy, I don't know where they are, right?
Diana Johns at Crestwood.
Oh yeah, well I mentioned that one, yeah. I'm looking at these ones from the other countries, like Skola, Virazden. I'm thinking somewhere in Poland. Okay. So I'll just talk a little bit about the data, but also a little bit about urban heat island effects, since I didn't prepare what I was hoping to prepare, since I wasn't feeling well, and then the ice storm and everything. This wasn't the ice storm on Tuesday morning. This was the ice storm the week before. I don't know if many of you had that, but you see the icicles coming off the branches. My son Timmy didn't have school that day, last Wednesday. And in Toledo, in Ohio, they had school. And so this point is approximately where our house is. And it's just about 6 miles north of Toledo. And that difference, the urban heat island effect, made a 1 or 2 degree difference where they didn't have the ice formation that we did at our house. Now, yesterday's storm everybody got a lot of ice in the area. So it didn't, you know, it was cold enough for everybody to have a lot of ice. Here's the schools. I actually didn't have a chance to see how many schools there are, and you see kind of concentrations in Ohio, Michigan, Croatia. I think all of us, we should go to Croatia. That'd be great. The Middle East and Taiwan. So zooming in. So there's a fair amount of observations, and interestingly, they're kind of in a line, a north-south line. And here's Croatia. You can see that it's an interesting shaped country there. Now, here's some observations from December 11th, and you might see your school's observations there. And we do have, you know, some rural areas and some urban areas, right? You kind of know that. I would call Shoemate rural. They're right on the edge of the suburban kind of stuff. And then Monroe, this is just outside of Monroe. Now I threw on here the satellite image. I don't know if you guys know, but in Globe, there's a lot of different satellite imagery you can get. You can do the comparison right there. One of the interesting things I think is, you know, how does the surface temperature compare to what the satellite sees? And what is interesting, and this is much colder, the surface temperature observation from the students is colder than what the satellite is observing. Why might that be? Well, on a cold morning in the winter, the air above it may actually be warmer. So the air kind of above our heads may be warmer, and the satellite will be including that observation of the air above it, and we're just doing the surface. In the summer, it's kind of the opposite, where the students would take observations that would be warmer at the surface than the satellite would see. Now, Matt, I think you're on. So I'm going to pick on Matt for a second. I don't know if I emailed you about this. So do you see how this observation in Monroe is colder than the rest? And it was colder than the rest a couple days earlier. So I'm thinking that your instrument's reading too low. And, you know, why would I think that? Because if you look at more than one day, and this is something students should do, is look at their data to see what is reasonable. Does it make sense? So if you see an observation that's much colder or much warmer than the rest, you might question it. Then if you look at multiple days and it's colder than the rest on multiple days, then you might suspect that there's a problem with that data site. So not trying to pick on your map, but it just happened that yours was the one that came up and that I wanted to use. The other thing I wanted to mention is you don't have to use surface temperature to do urban heat island analysis. So this is actually air temperature. And what's interesting, the surface temperature, is a lot of observations in Ohio and in Michigan, but the East Coast has a lot more air temperature observations. And here's, they actually are from weather stations. And so these are averaged over a month, or can be. And so you see these are the weather stations around the world that are uploading their data to Globe. And I did want to show, if anybody wanted to use this data, we got a station working at the University of Toledo right here. And then there's my house there. And this is actually a really good example. You can compare urban and rural right there between those two stations. One problem is my the computer wasn't uploading the data in the last month, so there's not a lot of data yet from that. Okay. So anyway, that's what I had prepared. So if I could have Diana's students talk now, I think that'd be great. And thanks for coming on, guys.
Hello, we're here. It's just a few technical difficulties here getting set up.
That's all right.
Oops. Yeah. I think we're almost there.
Press your screen.
Oh, no, you're going to click on Microsoft Power.
No, we got it right here.
Let me send you to
So we already hit share screen. I clicked on the chat.
No. Right.
Share screen. I got it. All right. Are we up?
Yes, you are.
Okay. All right. Well, we're here at Crestwood High School today. And this is, we've had 7 days off of school this year. So you can see where we're at. We've got the little star listed there for Michigan, where our site is kind of approximately. And I've got a picture from yesterday from our ice storm on the fence. I didn't have the kids take surface temperature data yesterday because it was so icy, but I actually came out because I was curious what it looked like at this site and took some data points for the kids. So we're just a suburban school just outside of Detroit. And we've been pretty active in Globe now for a few years. So just to give you a little bit of a history of where we've been, we actually got trained. I actually got trained back in 1995, but we really didn't get serious until we linked up with Dave Bedlowski through Wayne Risa back in 2011 through the ICRS program. And that got us really serious again. And that led to our involvement here at the school and a lot of different initiatives. I've got some pictures up, I think, of a few people that are actually watching the webinar tonight, but through being involved in Mission Earth, the AREN program. There's a picture of Marcy and I when we were part of the L2R program with Globe out in Colorado. So the reason why I wanted to mention this is because all of the in-service that I've been provided through Globe has really been pivotal in my students getting involved, because as I get excited and I get opportunities, that means that more opportunities are available for my students. And it's not just being a part of some of this in-service that has been provided by some of our local Globe institutions. It's also been the fact that people continue to support us. So, you know, Janet does a great job with Dr. C through University of Toledo and providing us with continuous updates of what's going on. And Dave, again, locally, helps us out a great deal. And last year it was really kind of a treat too, because Tony Murphy, Dr. Tony Murphy from the Globe office came to visit us at our school, and that was a big highlight for us. The students that I work with here at Crestwood High School, although they're part of my advanced placement environmental science classes, you know, don't take that really seriously like they're the brightest of the bright. They're great kids, but they're ordinary kids too, because what we do at our school is we actually try to lift up our students to do more than what they think they can. So as sophomores, we really encourage them to take APES, but it's, you know, we make sure that it's possible for all students. I even have special ed and students who have, you know, that are labeled ESL, that are taking the course. So we try to make it doable for everybody. So in my class, everybody learns the Globe protocols, but in order to participate in IVSS, you know, I take students on an interest basis. And the reason for that is because the kids who are really interested are the ones who are going to do the best job. And I found that when you require things like this, you know, sometimes it's just hastily put together and it doesn't, you know, really get the impact that you'd really like it to have. So we really got involved starting in 2013 because of the L2R program that I was involved in. And we got a chance to go to Washington, D.C., actually in Maryland. And my students actually did quite well in presenting their research, and they were awarded, I think this was the second year that they had students at an annual meeting doing research, and it was just a real treat because they came in the top 3 in their presentations. And that led to them really getting interested in issues locally. There's a picture here of them presenting their research to our watershed commissioner and our mayor. And this actually led to both of them getting nominated as watershed commissioners. And so now, actually, Sarah and Ali, they're sitting with me today, they followed in those same shoes, and we have quite a few students. We've got 5 students this year who are involved in our local watershed as a result of that. And that led to other things. So that led to some involvement of kids doing research in other local places too. We have a strong relationship with students doing research at the University of Michigan Dearborn campus at the Environmental Interpretive Center. We've had kids go on to take what they've learned in research in class to build a butterfly garden for blind students. We've got students who work in the organic garden. And that led to some students doing some bat research too by the local little pond that they have. And again, this led to more research the next year. The kids really that got interested in the Watershed Commission wanted to know why there was so much flooding in the southern part of our district. And so they started taking measurements of vernal pools and other parts of the watershed and doing measurements aerially and on the ground. And that led them to, as they did this research, it led them to get involved in the IVSS for the first time. They presented their research, developed the paper, submitted it, and they were fortunate enough to be chosen to go to India. And so there's a picture of Dr. C talking to them in India there as they presented their research. And so it wasn't so much of a competition as it was a symposium where everybody shared their research. And so they had it was probably, you know, a capstone experience for these students because they'd never been out of the country before. And so again, this one thing, I just want to get to the point of one thing leads to another. And so while we were in India, we met Dr. Danielle de Stark of Globe France, and she introduced us to a new type of photometer because we had been having trouble with some of our other photometers. And this led to students going on to do more research in aerosols that they presented, of course, at the Satellites Conference and also some of the first Midwestern science symposiums that were held in Toledo. And then that led to getting involved more. So we went to an annual meeting in Los Angeles where the kids got a chance to go to Catalina Island and do some great research. And again, to present their research to some of the other scientists that were attending the meeting. And then this led to the students who are sitting with me right now who decided that, you know, they'd done enough with aerosols. They learned all they wanted to learn, and so they wanted to do something else. And that brought up the idea of being involved in the solar eclipse, at least the almost total solar eclipse that we had a couple of years ago. So they got the whole school, they got the whole, you know, as many kids as they could together during the summer during that. And they took a lot of data over a 2-day period. And then they submitted that to the IVSS last year, and that led to them being chosen randomly to be given a stipend to help cover some of their expenses. And that gave them the chance to then go to Ireland, which was, again, one of those totally incredible experiences. It was one of those things where, you know, having the chance to speak with students from all over the world, and they'll probably say a few words about it in just a couple of minutes. It was just a really good experience. And of course, as Kevin said, you know, we're lucky to be hosting, you know, the annual meeting this year in Detroit. Dr. C, I know, and Dave Bidlowski are working on that a great deal. Somebody's got to wave to get the light here. And so again, if you're wondering how we do all this, how we squeeze some of this in, it's because my students are really hard workers. You know, they're here early, you know, 6:30 in the morning. They like, if they get here really early, they like their picture taken on the clock. And it's not uncommon for them to leave late at night. And it's not because they're procrastinators. It's just that, you know, they're like all of us. They're trying to squeeze a little bit more into an already packed schedule. And so one of the ways that we've tried to get some of this to work is to encourage the students who I've had as sophomores to do some research over the summer, because summer is a chance to collect data, not just for a week or a couple of days, but to collect it longitudinally over a period of time. And that's what leads to, I think, some of the good research that they submit. And then I work with them, even though I may not have them as students, I'll work with them the following year at school, and they'll put together their research and analyze the data. So again, it's a lot of work, you know, as a teacher, but really it's not as much as work for me. The pictures of the students here are the ones that went to Ireland last year. And I have to say that, you know, I truly was their advisor. I was their mentor, but they're the ones who went to the library late at night. They're the ones who met up with each other at the house and did the research. So again, we've got to remember it's the students doing the research, not us. We're just there to guide them. And I'm always thankful to all of the Globe scientists that have really gone out of their way to answer some of the questions that my students have asked. That's been pivotal in them getting involved because, again, they don't go down too many blind alleys that way. So, again, the great thing about the Globe website is that all you have to do is go to the search bar, and there are so many helps, some of the ones that Dr. C put up in his presentation. There's so many ways to look at past webinars. There's so much data, you know, the rubrics are there. So everything is easy to get at. And I found that some of the information that's there is really suitable for the students to look at. It's not something that I have to view and then, you know, talk to the students about. I put them and make them in charge of getting that information. So the rewards are great. Most of the rewards are intangible ones. I mean, you know, public speaking skills, the experience of going to other places. We went to Purdue a couple of years ago, and that was just a tremendous experience that really opened up the eyes of a lot of the students that attended. And then there's, of course, it's always the tangible rewards, of course. If you get a nice trophy, that's always pretty cool too. So again, as a teacher, we always wonder, whether or not doing all this and all this extra work actually counts. And so when Dr. Murphy came and visited our school last year, it was really kind of nice. I had some of my former students come back to talk about what role Globe Research had played in their life now that they're in college. And I have to admit that it really brought tears to my eyes, because everything that you would hope for that would happen with your students was things that they talked about. So that was a really gratifying experience. And so again, in terms of IVSS and student testimonial, they'll tell you they love Globe. I mean, we talk about Globe all the time, and it's Globe. It's all of the spin-offs from it. It's ICRS, it's AREN, it's Mission Earth. I can't thank you enough for supporting the student research, because it's one thing for students to do research. It's another thing to know that they're submitting information that's going to be used by scientists, and scientists are going to look at and make comments about. It's just so much more meaningful for them. So with that, they'd like to talk a little bit.
Okay, hi. We're just going to start by introducing ourselves and how many years we've been involved with IVSS. I'm Ali. I've been involved with IVSS for 2 years.
And I'm Sarah. I've been involved this is my 4th year.
And our sophomore year, we submitted a project on aerosols, like Ms. John said. And then last year, we took advantage of the rare 2017 North American solar eclipse, and we ended up doing our project on that, and we ended up, going to Ireland with it, as we'll talk about later. So we just kind of wanted to talk about how IVSS works, how we analyzed our data, how we took the data we gathered and we made a project out of it. So first, start off with retrieving our data. So one of the requirements for IVSS is submitting your data into the Globe database, which is what we did. We like doing it every day after we took measurements. So for example, for our aerosols project, as soon as we went outside and took measurements on AOT values, aerosol optical thickness values, we came to our computer in our little workroom, and we submitted our data and put it in the Globe database and into a spreadsheet. And through the visualization system, you can easily access all the data you put in from any given time, any month, any day, and it'll all be there for you, which is something that's really cool. We added some pictures on how to access the visualization system. And also what the data looks like once you can access it.
Okay, so like Ali was talking about, wait, I'll go back one more. Okay, so what's so great about the Globe visualization system is that you really can compare your data as compared to everyone else taking data measurements on this same exact thing. So it's all there for us. We have students taking data on multiple different things. So we were focusing on aerosols, but at the same time there were other students taking data on surface temperature. So it was all there for us. It was really easy to retrieve. Also about the visualization system. So Dr. Siri covered this, but basically if you wanted to see on a specific day, and then the aerosol data for that, you could see our school, Crestwood High School, that took data for that day, but then I could also see a bunch of other schools that also took data on the same day. And so that was really cool, because we were able to actually compare our data to theirs. So what happens is that after I clicked on my site and then go on the measurements and everything, you can get the data all in a data table, and then if you export it, it will make it into an Excel sheet. And then this was really easy to use afterwards, because we then use this Excel sheet to make all our graphs and everything to look at one thing as compared to another. So yeah, this was really helpful.
Yeah, and we found that in Excel, we could have made graphs on the visualization system, but what we found is that in Excel, it was very useful in handling the large amounts of data that we had. And also, we found that Excel was more suitable for statistical analysis. And as you'll see in some of the graphs that we show you later on, we did conduct some statistical analysis to find correlations between two different variables. And so this is how we analyze the data. So using the visualization system in Excel, we were able to make graphs like how we like you can see on the PowerPoint, and we were able to compare our data to analyze trends that we saw. So for example, we had two different types of photometers. The Calitude that was given us by Dr. Danielle Stark. And then we also like compared our AOT values to certain weather parameters such as barometric pressure, sulfate particles, like all that kind of stuff. And so what we found was that we could use the visualization system in Excel to make the graphs to compare side by side our data that we got from our Calitude, which is one of our types of photometers, and our globe photometer. And we found that there was a significant enough difference where the instruments were different enough to show like a difference in data, but overall the trends look pretty similar. And also the visualization system, as Sarah said, allowed like us to do some really cool things. So we looked at for schools who were in our similar like latitude, and we found a school in Croatia, and we were able to compare our data. Of course, we were limited by the days that we had in common, where we both took data at the same time. And so what we ended up finding was that overall there was a pretty similar trend until there's one outlier, and that could have been due to anything such as cloud coverage or anything like that. And so without the globe visualization system, or IVSS, we wouldn't have been able to even do any of this or compare our data with another school. And what we found is that when we presented our data, something that really stood out in our like research was that we were able to compare to other schools in similar latitude, and that we took the time to use it to find the visualization system and really utilize it to like apply our data and to compare with other schools and like show how our findings affect other like affect the real world and how it compares to other schools.
So over here, we are only showing our data for aerosols and how we compared that to another school. But as you said, like our recent project about the solar eclipse, we were able to compare to schools, I think, in Ohio. So we've also found like we didn't input the graphs here, but we also found like really cool, interesting things when we compared our two schools together, and we actually found like as our data, like as our values like when increase, like their values like decrease or whatever. So that was also really interesting, like getting to compare our data from us to that school. So because we actually found like something that was very interesting with that. And then training the next generation, there are new groups now very interested in Globe after seeing like all the Globe alumni, and so they're actually working on a project right now about surface temperature. They just don't know like what angle they're going to take on it right now. But so me and Ali have spent the last couple months teaching them basically how to use the Globe visualization system and really how to like take like what they want out of it, what like all the different type of cool things that they can use from it. We're also showing them how they can like export all that data, and then also like basically like what we just showed you guys about how we made our own graphs and trend lines and use statistical analysis to see like correlations in R-squared analysis and stuff. So yeah, that's what we've been working on, and just really helping like inspire them to also start their own Globe projects.
Yeah, I think the coolest thing about our involvement in Globe is I think that like more than ever, especially when we got involved, people started noticing, especially after we went to Ireland, after we did the solar eclipse, like Ms. John said about the community engagement. You saw the picture of everyone with their eclipse glasses on, like they all came wondering what we were doing, like asking if they could stay and like watch the eclipse occur with us. And I think the coolest thing about when we were in Globe is that we got so many people involved in it, and that we got so many people interested in it. More people than ever have been coming up to Ms. Johns and asking her, how can I get involved in Globe? How can I participate in the IVSS? And I think it's partially to do with all the cool like opportunities we've been given, like the places we went, like seeing us like travel and like going to symposiums and all these cool things. And really like I think it's just really awesome because we get to have more kids like involved in science and it's what we need right now, because as Dr. C said, it's important that we take data. Like, for example, like what he said about the surface temperature, satellites are great at collecting data, but data taken by hand is just as important for something that satellites can't catch. And I think that's really cool that we're like citizen scientists, like that we actually get to like participate in this ourselves and get hands-on experiences like this. And it is a capstone experience. It helps you with research, it helps you with presentation, like social skills. Really, like at Ireland, like we met the coolest people ever, and like yeah, there was a language barrier, yeah, like they were from different backgrounds than us, but it really taught us how to like thrive in different settings. Like how many people could say they got to go to Ireland and meet people from all over the country and really like cooperate with them to take data and learn how to become better researchers. It's just all around a great experience, and we all owe it to the IVSS and like this Globe program. So.
there's any questions.
So if anyone has any questions, we're open to take any.
Yeah, any questions for Sarah and Ali?
This is Larissa. I'm from Boston. How are you? Thank you for a great presentation. Amazing work, and your enthusiasm is contagious, I would say. So thank you. I think you are doing very well, and you're doing an amazing work with your teacher, and I hope more students and teachers will follow your footsteps. Just a quick question. Your teacher used an example how early students arrive, 6:30 in the morning. So I assume your parents are very supportive of you coming to school before. So I guess my question also related to, is partially Globe included into some elective, or this is just after and before school activity? Thank you.
So like Ms. John said, it's a part of our APES program. So she does train every APES student on the Globe protocol. But like Ms. John said, it's all submitting a project to the IVSS is not required as part of the course. It's something that's voluntary. So the protocol is something that we require that students learn, that we do train them on it, as we think it's like something good for them to know. Because undoubtedly going into those fields, you'll have to know those things, and it just prepares you well for whatever course of study you're going into. But it's not a required part of like the course or like the elective or anything like that. And most of it is voluntary. You go to Ms. John, say, this is what I'm interested in. Like, do we have the instruments available to conduct research on this topic?
Also, Mrs. Johns is also our NHS, our National Honor Society advisor, and we've also kind of been able to incorporate it through NHS as well. So on our NHS website, we have like a whole section dedicated to Globe, and it's basically just to get anyone involved when they're looking at our website, that they can also look at it and look at some of the past things we've done. I know, like, for example, for our solar eclipse project, we encourage a lot of our National Honor Society students to come watch the solar eclipse with us, and like basically just try getting as many people in as possible. And that alone, that stirred so much enthusiasm for trying to get involved into Globe as well, because we already showed the picture and we discussed it, but basically when you drove past our school, and then you see all those people going down and looking at the solar eclipse and trying to, and then they asked us about what we were researching, and we got some of our National Honor Society students to help out and take some of the measurements with us, because we were taking so many measurements simultaneously. So we've been able to incorporate it through Mrs. John's APES course and also our National Honor Society, just to get as many people as interested in it as possible. And a lot of people have been coming up to Mrs. John's recently and been at really wanting to start a project. So
when you say APES, I'm sorry, English is my third language. So you mean AP Science?
AP
Yes.
Environmental Science, yeah.
Okay.
That's an acronym we know because Ms. John drills it into our head.
yeah.
It's much easier.
Yes, absolutely. Thank you very much for the amazing work you're doing. And again, keep progressing, and good luck. And I will share it with all our students here in Massachusetts. And I'm sure they would have more questions for you and your teachers, but the most important thing to share with them is your enthusiasm. So hats off to you and your teacher.
Thank you so much.
Of course.
And Jem Bourgeot, she's wants you to make video tutorials now. If you haven't already.
We'll be sure to.
So I was like, well, actually, that's a good way to make it last year after
Yeah.
year.
I have a quick question for you guys. So this is Sarah. I came to your school, I think, a couple years ago and interviewed you guys.
Yeah.
Yeah.
Yeah. Can you talk about just real briefly, personally, how you've changed or evolved since the time you first got involved in Globe until now?
Yeah, okay, I'll start. So I actually started my freshman year with Globe, and I remember I was teamed up with a group of 2 other juniors. So I was still a freshman and I was with 2 other juniors, and then I remember one knowing very little about the program, and I remember being going to Miss John's telling us, so there's this symposium in Toledo, and I was so confused. I was like, what is she taking me to? And it was really it was all just so new to me. And then so I remember the first time presenting and being extremely nervous, and it was just it was this whole new thing to me, but I can proudly say that, like, I mean, from since then, and then we went to Ireland last summer. So like I have grown like immensely, I think I'd like to say. It's been like such a great experience, and I've learned so much again about like there's like the smaller things, so like the presentation skills and just getting to talk to new people and like learning about what they've done, and like being like so excited about like what they've been involved in and like how that affects like where like they live and like what they're interested in and stuff. And then there's just like
Talk about the college application process.
yeah, okay. And then also like basically, so since we're both seniors, we both just finished applying to colleges and stuff, and like what you learn, like the experiences that get from Globe is what you talk about, like I guess in the college application process. So it's not so much necessarily about like writing it that you've been a part of this, or like writing it like as part of your resume, like this was one of the activities I was involved in, but it's really like what you take out of it, and then all the different things that you've learned, the people that you've met, and like it's something that like I've grown so passionate about, and I've been able to talk about it in like all my interviews and everything with all these like administrations representatives and stuff, and just talking about how it's been such like an integral part of my high school years.
Yeah, I'd agree. So I guess the biggest way I changed is I never thought I'd become like so passionate about something. Like Sarah said, you didn't realize this because when we were sophomores, we weren't thinking about college applications. But now that college applications came and went, like it just like, because what you do in college applications is you write about things, experiences, things you've done, like all that stuff. And what I found is that it was hard not to like write about Globe every single time, for every single essay, for every single prompt, because that's what we're most passionate about. Like Sarah said, our interviewers could, like you, Larissa said, like they could like sense our enthusiasm. And that's what really translates. Like through the in-person to person interviews, like enthusiasm really translates when we're talking about our experiences at Ireland, like presenting in front of like world-renowned scientists. And I think that was like the coolest part, because like my favorite essays are the ones about Ireland. Like I guess like the biggest way I've changed is I never thought I'd be so passionate about something. I never thought I could grow so much from something. And like it really shows, like as I compare like my freshman year self to my senior year self. And actually I just thought I'd throw this out there. Sarah just got into Harvard, her Harvard essay was a lot about Ireland, so I thought that was really cool. So I didn't.
I do.
Congratulations. That's
Thank you.
fantastic.
Congratulations, and you will be in our area. You will be next week. I am in Cambridge, in Boston, so stop by anytime, and we would love to get you in our classrooms as a Globe alum. So, yay! Congratulations.
Thank
so
you.
proud and happy for you.
Thank you.
Well, thanks, Sarah and Ali. We should now show the video from Nektaria, and you know, like I said, she spends time in Greece and then in West Virginia and goes back and forth. Anyway, and Sarah's going to show it. So
Yeah, hold on.
we'll have to see. So I can, when I talk to Nektaria, I can tell where she is by you know, what country she's in by the background. You know, the house.
Okay, can everybody see that?
Yes.
Okay.
Hello everyone, my name is Nektaria Adaktilou. I am an atmospheric physics and remote sensing scientist, and I work at West Virginia University. I'm happy to be with you virtually. Yes, I am in Athens, Greece, so at the time of the webinar it will be like 3 o'clock in the morning for us. I will be presenting to you a project I put together with some of our students at the university for the assessment of the surface urban heat island for Morgantown. So Morgantown is in Monongalia County, West Virginia. It is along the banks of the Monongahela River, and it's the largest city in north central West Virginia. It is home to the West Virginia University, and also to the West Virginia Mountaineers and the Morgantown Personal Rapid Transit System. So the university, and in specific the Department of Geology and Geography where I work, requires that senior undergraduate geography students take a capstone course that integrates some of the principles that they have learned over their 4 years. Usually students will work in groups of 3 or 4, And they have to come together with a hands-on project that they will then design and execute that will address one of more of those principles in detail. At some point, I had talked to some members of the faculty and some of the students about GLOBE and about the Urban Heat Island campaign. So when it was time for them to put their project together, they thought they would like to work on that. And that's how one group of students, 4 students in specific, gathered surface temperature, air temperature, relative humidity data using the GLOBE protocol. The students sampled higher, medium, and lower density residential areas and also natural surfaces, and related their findings to the physical properties associated with each plant use. What they did eventually is that they compared the data that they themselves collected to satellite data coming from LandSat 8 and using a land surface temperature map that was produced by the USGS. We started this project by talking about the urban heat island. The students were aware of the phenomenon. However, they did not know in detail what were the causes and what were the consequences, and they had not thought through about why it is really so important. And we said that we were going to work in specific about the surface urban heat island that's present all times, day and night. It's most intense during the day and during the summertime and has significant spatial and temporal variation. We talked about the significance of surface temperature, that it represents the heat that is given off by the land, the buildings, and other surfaces. And we talked about technologies that measure temperatures of surfaces, such as instruments mounted on satellites and airplanes, can provide a very good geographic coverage. They can reveal temperature differences at very satisfactory scales, for example, between roofs, pavements, and grassy areas. We also talked about some limitations, of course, when it comes to satellites. They do provide a very extensive geographic coverage, but they cannot necessarily portray the finer detail of hotspots within the neighborhoods because trees or tall buildings may prevent satellites from accurately capturing the temperatures of surfaces at ground level. And then again, data can only be collected during the times when the satellite passes over the city, and data is available only for clear weather conditions, which could be a challenge for us in Morgantown since we usually have 2 to 3 good satellite images per year. We also discussed other options, such as, for example, having surface temperature data from aircraft-based instruments or from UAVs. And these, of course, offer higher resolution than those from satellites since they fly at lower altitudes. But we talked about limitations in this case as well, since there is an irregular coverage and it can be quite expensive to plan and get the data from such missions. And then, of course, we discussed in detail what the campaign does with the ground-based thermal sensing, with having people with handheld infrared thermometers that are pointed at surfaces to measure the temperatures and how these can be used to get surface temperatures for specific urban features. For example, parking lots versus city parks or different surface types, such as light-colored roofs versus dark roofs. Our objective in this work was to identify where are the hotspots and the cooler areas within the city. That would be the first step. So this is what Morgantown looks like in a LandSat 8 image. The areas that look green are the ones that are artificial surfaces, represent artificial surfaces, while all the red areas with the different shades of red represent vegetation that can be of different types or can be of different density. And then this feature that's dark blue is the river that I mentioned earlier on. So the LandSat satellites since 1972 have created the greatest continually acquired moderate resolution data archive. It is a joint USGS and NASA initiative that supports worldwide remote sensing studies with data which is very useful for scientists, for land managers, for decision makers, so as to make well-informed decisions about the environment and the use of the natural resources. What we discussed with the students were the specific characteristics of the sensors on board LandSat 8, as we were going to use the visible bands and we were going to use band 10 for the infrared. And also talked about the process of acquiring the satellite image. The first step for us to plan what we were going to do was to go into the acquisition calendar in landsat.usgs.gov, and knowing the path on which Morgantown is found, to identify the date for which we would have the overpass. So that would be the date when the students would go out and take their measurements that they would then compare with the satellite data. So we were very fortunate because the specific day was sunny and clear skies, which is quite unusual for that time of the year, as I mentioned earlier on. And you see in the picture those 4 students that were involved. And also you see Professor Rick Landenberger, who also is faculty at the West Virginia University in the Department of Geology and Geography, and who helped us that day for the measurements. We discussed in detail what the students were supposed to do and what they were not supposed to do so as to get good measurements. Everyone was provided with a map so that they would know exactly where they would go to take their measurement. And of course, the respective tools, the infrared thermometer and the instrument for the air temperature and the relative humidity. We also went through the globe data sheet for the surface temperature to make sure there were no questions and everything was clear as to what process was supposed to be followed. One of the students created a data collection app in ArcGIS, which was proven to be quite useful. And this is all the data that was collected on the specific date, presented in an Excel spreadsheet. Now, the next step would be to go on Earth Explorer and actually get the images from Morgantown so that we could continue with the processing. And I talked with the students and discussed in detail about how we could go from having digital numbers to converting these to reflectance or to surface temperature. And this was explained in detail as a step-by-step process. However, the students preferred a different approach, which we had discussed, of course, and that was to go on the Earth Explorer page and get the LandSat surface temperature as a product, as a map that was provided by the USGS. So what they did, since they had the coordinates for their measurements, is they actually overlaid their own measurements on the map. And then we made a comparison there, and we can see that there's a good agreement because the higher temperatures are where we can see the red and then the orange areas. And as we go to the yellow and the cyan and the blue ones, we have the lower temperatures. So it looked like there was a good agreement with what the students had made. So the students were very excited about participating in this process, and we are actually thinking of doing this again, having a larger number of students and then making the comparison with the temperatures that they measure and the ones that the satellite provides, and also looking into the thermal comfort in the city. For those who are interested, this is the link that you can use to access this data, the land surface temperature maps, and then compare to what the students collect by themselves using the infrared thermometers. The students used their data and they also took pictures and videos and they put together a story map which they presented for their class, and they actually did quite well. So this is the first the opening page for what they created, exploring the urban heat island. And these are the names of the students who participated: Amanda Adams, Reed Croft, Rachel Taylor, and Walter Bolt. Again, Dr. Rich Landenberger. And here's the link to the story map for whoever is interested in seeing in more detail how the students worked and what was the entire process that they followed. If there are any questions, you can use my email and get in touch. And if you would like to have more details or any clarifications about the work that was done. Thank you.
Well, that was a good presentation of, how to do the remote sensing part. Does anybody have any questions that I might be able to answer?
No, just express our appreciation to Nektaria. It's not the first time when I'm attending her virtual presentations. So please send our thanks to her wherever she is now. Looks like she's living a very active international sort of travel
Right.
life. So I liked very much presentation. I shared it with my teachers and students. So just thank to Nektaria.
All right, great. All right.
Deb,
sorry.
Deb asked earlier if you could show her how you were getting the information from Globe.
Well, and what I could, we don't have a lot of time right now, but I can show your class too. So I'll show you just a minute here. See what we got going on. All right, so if you go to Globe Visualization, click on the visualization, and hopefully it works okay. When we do the web stuff, it sometimes slows things down. These pizza boxes are have your data separated by a sphere. So then, well, there's lots of different things we can do. I like surface temperature, so I always pick that one. All right, and so then it shows today's surface temperature. Not a lot because we're not really doing campaign, but I think that's Jeff's kids there took observations today. You can change any date, right? Especially then you can go through field campaign, December, say 13th. Let's see more. I can zoom in and out. All right. All right. When I do the remote sensing part, I go to the base layers. Those three dots. You wouldn't necessarily know that that's base layers, but it is. Choose a base layer. So then there's actually a number of satellite imagery. Now these are all MODIS and the Terra, and this is a SUMI NPP, but Terra, the satellite imagery is 1 kilometer spatial resolution. So the LandSat, which Nektaria uses, higher spatial resolution. These are all lower spatial resolution. And so you just click on that and it comes up for the world, which is pretty sweet. And of course, there's blanks where the clouds are. So this only works, the satellite only works when there aren't clouds. And then again, you can change the date. And so, this is a project right there, right? You got your satellite, you have your data, and you can compare it. Like I said, tough to find it when the satellite, when it's clear. So that's kind of what, we kind of do for publishing papers, is comparing the satellite to the ground observations. You can do that with the aerosols. You can do that with SMAP, precipitation. All these different things you can look at. Anyway, I don't know if that's helpful.
Thank you, Kevin.
I think the other key, if you click on these three dots, view layer table. And that's how you get your data. That's on the screen. There, our chat says. Oh yeah, so Jen asked, do the colors match the colors of the dots? They do. So the same temperatures. And Marcy asked if I've noticed any trends between more than urban and rural. No. It's pretty much looking at the urban and rural. And urban includes residential. So it's, you know, neighborhoods and stuff like that we count as urban. But I haven't really seen other trends. Now, this topic is very interesting to people worldwide. So, you know, these cities are growing around the world, much more so than in the United States. So in other countries, so people in other countries are very interested in urban heat island because, you know, the Earth is warming up, and their urban areas are getting bigger, and they're having smog problems, which is related to the temperature, and then they're having heat problems. So anyway, that's something to mention, I guess, is that it's a big issue. All right, so I want to show. All right, so I'll wrap up for today. I'll show you the last slide because these are our social media links. And the webinars are put on our YouTube page. And actually, if you ever just type in Globe Mission Earth in Facebook, YouTube, or Google, our stuff comes up. I'm just reading Jen's text or message here. Right. So what Jen is saying is that you need more measurements in an area when you're comparing a point to a 1 kilometer area that could be problematic. What's interesting with SMAP, I have found it's actually okay, where you see this trends, they match each other with the soil moisture. All right. Well, let's see, the 3 dots area you showed have never been explored. Not sure what you're mentioning there. Oh, I see what you're saying, Debbie, that the 3 dots on the Globe website have never been explored. Because who knows what those 3 dots mean, right? And I'll tell you, when they switched to the new visualization system, and they didn't even have those 3 dots, it took me, I think it was 8 hours to figure out how to get the data out in a table. I spent a lot of time doing that. All right, I wanted to thank everyone for joining us today, and thanks all the speakers. Sarah and Ali, congratulations getting into college and getting into college. It's great, and hopefully get some funding with that. And you guys have a good rest of your day.
Thank you, and we hope you feel better, Kevin.
Thanks.